Okay, today's lesson comes from the textbook, section 3-4, Systems of Linear Inequalities. You can see our goals are to write and graph a system of linear inequalities in two variables, write the system of linear inequalities in two variables from the given region. So in other words, if I give you a graph, you should be able to write the inequalities. If I give you the inequalities, you should be able to write and graph them in a correct form. I believe we've done some of this in Algebra 1, so let's move to that. Let's start with the system. Y is greater than 2x minus 5, and the equation 3x plus 4y is less than 12. Now, as a reminder, we have a couple different ways to graph, and I'm just saying up here, let's use what they give us. So, in the first one, it looks like slope-intercept form. So we're going to start at that negative 5. And from there, go up 2 over 1, up 2 over 1, till we have our designated line here in yellow. And it is dashed or dotted because it was a y is greater than. It is shaded above because it is a y is greater than. So we graphed the first inequality and did our shading. And we used the yellow. Now, this is what you probably remember. Some of you used colors on this. Some of you used different styles of lines. The shading is going to be key as we move forward and finish by graphing the second one. Now, I say here, let's use the x and y intercepts on this one because it already is in standard form. So if we start thinking ahead, that would mean c over b, 12 over 4 is 3, and c over a, 12 over 3 is 4. So we have two intercepts fairly quickly and able to graph them. So let's go and do that on top of the current graph. And you will see that we placed our x-intercept of 4, 0, 4 comma 0. We placed our y-intercept of 0, 3 right there. And from there, we drew our line. And again, our line is dotted or dashed because of our inequalities. Whoops, did not mean to move that down. So, with our line dotted, dashed, we should be able to see, and I also moved the shading a little, we should be able to see that we have a region. And that region is now where the yellow and blue overlap. And so we have two dotted or dashed lines, and for whatever reason it's not dotted on this page, but it should be, with the green region as our final solution there. So step 2 was graph the second inequality in shade. Step 3 is to look back and identify your solution. Now, it's very clear on this one, and we'll pull out the arrow to show you, that this space right here that turned to the green is what we call the double shaded area, and it represents the solution of the system, where both equations will make it true. So in other words, if you were doing the test point before, you would choose a point that is in this region, and if you did, pick something easy. If you picked the 0, 0, which is an easy point on this one. My board is working really slow right now, so if we pick 0, 0 here and plugged it in, that 0, 0 will make both those equations true. And so therefore you should have this region that we already have double shaded as your solution. So you've done these before. You're going to just have to be careful drawing your lines, shading each line individually first, and where the shading overlaps is the key region. Now, if you don't like doing the color thing, and you can just do, I like to do an arrow thing. You said when you drew this yellow line that I knew it was shaded to this side of the line. So you just make little indicators. You don't do any shading. And then when you drew the blue or second equation, you said I knew it has to be shaded to this side of the line. So that your final shading and only shading that you would have on your paper would come from this place that is double shaded. So if you want to only shade the final region, that is absolutely correct and appropriate, and sometimes less confusing with all the colors and shapes and whatever you do to shade. So that's what we're going to do. Two equations, inequalities, leading up to our last section that's coming up. So that's all there is. Happy shading.